So if you look at the critical points between 0 and 2 pi, they're pi over 6, 5 pi over 6, and 3 pi over 2. I'm only going to kind of look at how the function reacts between 0 and 2 pi and see if we can locate what's going on. We're going to look at where it's increasing, decreasing, if there's local maxes and mins. So pi over 6 is 30 degrees. If you looked at what I put here in yellow, the sign between 0 and pi over 6 is positive, so that would be a negative value. And then the cosine of a value between 0 and 30 doubled be 60, so that would be a positive. And if you were to put it into a calculator, you would get a positive value. And then if you pick a number between pi over 6 and 5 pi over 6, that is a negative. And then if you get from 5 pi over 6 to 3 pi over 2, and you pick a number there, that is a positive. And then if you go from 3 pi over 2 to 2 pi, that would be a negative. Okay? So now let's look at parts or maxes and mins, what's happening. So pi over 6 to 5 pi over 6, it is increasing and then decreasing. So we consider pi over 6 is a local maximum. At 5 pi over 6, that is a decreasing and increasing. At 5 pi over 6, that is a local minimum. At 3 pi over 2, that is a local maximum. Excuse me. Okay, let's talk about the concavity. So we need to find the second derivative. Here is the second derivative. Again, we're going to use our trick where we are going to plug in an alternative form of the sine of 2x so that we can factor it. We get negative 2 cosine of x plus 4 times 2 sine of x cosine of x. If we set that equal to 0, we can factor out a 2 and a cosine of x. We are left behind a negative 1 plus 4 sine of x. So we're looking for where is the cosine of x equal to 0 and where is the sine of x equal to 1/4. Now, we don't really have a place where we think of the sine of x equaling 1/4. You know, if you think about where that's located, that's roughly about 14 degrees. So if you think about it, excuse me, that would be, you know, between 0 and pi over 6. So something is happening there. So now we're going to make a plus minus chart. We're going to look at 0 and 1/4. I am going to plug in 0 for a minute there to see if there's maybe a chance that there's a change in concavity. But if you look, if you plug in something to the left of 0, it's going to be a negative. If you would plug in something between 0 and, I'm going to write for the sake of thinking, 14 degrees, you get a positive. No, actually, I'm sorry, that's a positive, that's a negative. So I had a slight little error there. If you look at my first derivative, it should have 2 negatives there, okay? Now the cosine is equal to 0 in 2 spots between 0 and 2 pi. The cosine is the x value, so that would be pi over 2 and 3 pi over 2. And then the sine is negative 1/4. Now I'm going to think in degrees a little bit just because it will kind of make a little bit more sense. That would be negative 14 degrees. Or if you go in the third quadrant, 360 minus 14. Or you could think of around just before 2 pi. So it's just before 2 pi. Okay? Okay. So now we need to make a plus minus chart for that. Now really, again, I'm just doing one cycle between 0 and 2 pi, because once I get that, I can figure out where I'm at. So I'm going to put on there pi over 2. I'm going to put on there 3 pi over 2. And that negative 14 is the same as 344 degrees. So it would be just before 2 pi. So assume that's where that's going to go. Okay? So let's look at the concavity. If you plug something between 0 and pi over 2 into the second derivative, which was right here. If you plug that in between 0 and pi over 2, it is negative. If you plug something in between pi over 2 and 3 pi over 2, it is positive. If you plug in something between 3 pi over 2 and that just before 2 pi, so that 344 degrees, you get that it is a positive. And then if you put in something between that number and 2 pi, you get a negative. So we have points of inflection at pi over 2, and at that, let me write this a little nicer. So we have a point of inflection at pi over 2, or that 344 44 degrees. Okay. So now we finally have enough information to graph it. So what are you going to do? Well, you're going to need to plot some points besides the red points I already have on it. And remember, this is a graph that is a wave. So let me kind of move this a little bit so I can really zoom into our graph. Okay. Okay. So the points that I decided to plot were 0 is at 2. Pi over 6, I got 2.6. That was a local maximum. At pi over 2, we were at 0. We kind of knew that, so that's going to go up and down. At 5 pi over 6, we're at negative 2.6, so that's about down here somewhere. At pi over 2, we're back at 0. At 13 pi over 6, just after 2 pi, we're back up at that 2.6, but at 2 pi we are at 2, so that's why we've cycled back around. Okay. Now actually the concavity is wrong in that spot. That actually goes, sorry about that, let's see if I can get it looking a little nicer here. Okay. So this is a periodic function. So that cycle will do it again. So you could do that exact same thing, come up, down, around. Doesn't want to graph in that section. There we go. Okay. Now what do we know? We know that there was a change in concavity here. See how it goes from up to down. There's a change in concavity or point of inflection here. See where it goes there and there. It should be fitting all the increase and decrease in max, mins, and everything else that we see. So that's a really kind of a difficult problem, but I did want you to see that. So there you go.